Hello everyone, this is a continuation topic for previous video, that is nothing but SVM algorithm. SVM algorithm is support vector algorithm. So we have two types in the support vector algorithm, that is linear SVM and non-linear SVM. Linear SVM in the sense it is used for linear separable data, which means if a dataset can be classified into two classes by using a single state line, then such data is termed as linear separable data, and the classifier is used as called as linear SVM classifier. That means when we have two classes, easily we can separate by using a one single line, then that is called as linear separable data. The classifier used in that linear separable data is linear SVM, okay, support vector mission. Whereas non-linear SVM is used for non-linearly separable data. That means, which means if a data set cannot be classified by using a straight line, then such data is termed as non-linear separable data, and the classifier used is called as non-linear SVM classifier. When we have two classes, easily separable data by using a single line is called linear SVM. Whereas we have a two or more classes that cannot be separated by using a single line, then it is called as non-linear SVM. Let's see how. First we'll see in this video about linear SVM. The working of the SVM algorithm can be understood by using an example. Suppose we have a data set that has two tags, green and blue, and the data set has two features, that is x1 and x2. We want to classify then that can classify the pair x1 x2 of coordinates in either green or blue. This is the classifier we have. We have two tags, green and blue, and we have to classify them as the pairs x1 comma x2 of coordinates in either green or blue. Let's see this image carefully. We have green and blue tags for these. So as it is in the two-dimension space, by just using a straight line, we can easily separate these two classes. But there can be multiple lines that can separate these classes. Consider the below image. We are using a straight line to separate the two tags, or else we are using a slant line to separate the two classes. Okay, your wish, but we are using only a single line to separate these two classes. Then it is called as linear SVM. Okay. Hence, the SVM algorithm helps to find the best line or decision boundary. This best boundary or region is called hyperplane. I also said this hyperplane in the previous video. SVM algorithm finds the closest point of the lines from both the classes. These points are called support vectors. It uses the closest points of lines from both the classes. The closest point of the lines is called as support vectors. The distance between the vectors and the hyperplane is called margin, and the goal of the SVM is to maximize the margin. Okay, this goal of this SVM is to maximize the margin. The hyperplane with the maximum margin is called optimal hyperplane. Exactly in middle it will be drawn, so that is called as a hyperplane. See, this is blue and green tags are called support vectors, whereas which is the nearest to the margin, then only it will consider and the line will be drawn here. That line is called optimal hyperplane. Okay, this blue and green tags is called as what? Support vector, and the line which is separating between the one is called optimal hyperplane. Let's see now non-linear SVM. Non-linear SVM is nothing but if the data is linearly arranged, then we can separate by using a straight line. But for non-linear data, we cannot draw a single straight line. That is the difference between the linear and non-linear. In linear, we can easily draw a single line, whereas in non-linear, we cannot draw a single line. Why? Because it consists of non-linear data. Let's see this image. It is not even having a separate from blue and green tags. It is all mixed up with green and blue. So we cannot draw a line by using a single line. So what to do? So to separate these data points, we need to add one more dimension. For linear data. We have used two dimensions, that is x and y. So for non-linear data, we will add a third dimension, that is z. It can be calculated as z is equals to x2 plus y2. By adding the third dimension, the sample space will become as below image. By adding this third dimension, the space will become like this, and we have reduced some of them from the dimensions to the small dimension by using the z dimension. So now SVM will divide the data sets into classes in the following way. Consider the below image. For this, after coming this image, we are segregating into a best hyperplane by drawing in the lower boundary. We are going to draw a best hyperplane. Then if we draw that best hyperplane, the image looks like this. Since we are in the 3D space, hence it is looking like a plane parallel to the x-axis. If we convert it into 2D space with z is equals to 1, then it is become as like this. If we consider z is equals to 1, then it is reduced to 3-dimension space into 2-dimension space. The image looks like this. Hence we got a circumference of radius 1 in case of nonlinear data. This is the way to convert the nonlinear data. For the best hyperline, we are using the z formula, that is z is equals to x2 plus y2. Then we can get a reduces of a dimensions. If we want to add the dimension, we use z. Or if we want to reduce, we will keep as z is equals to 1 as the circumference. Then we will get like this. In this, we can easily see that we have separated the green tags and the blue tags by using the best hyperline. Okay, this is called as the nonlinear support vector mission. Okay, thank you.